Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the summary of chapter 1 up to 11. So this is the reviewer for the chapter 1 to 11. So this is the summary. Networks and the internet have changed the way we communicate, learn, work, and even play. So the network or the internet uh, has a big change for us. So the first is the how we communicate. So we easily communicate to others. So through the social media. So unlike before, so we having a hard time in communicating with others away from us. So now we have the Facebook. So the messenger. So we can uh, easily communicate to others with the use of messenger even they are miles away from us. Then how we learn, so we learn a lot of things through the internet. So if there's things that we didn't know, so we'll just search it in the Google or in other applications, so we can learn from that. Then the work, we are working through the internet, so we can work. So like the online shopping, so it uses the internet for us to have a work. So even uh, the other institutions, so they are using the internet to improve or to innovate uh, their product. Then even we play. So we play different games through online. So there's different games that uses an internet that you play. Networks come in all sizes. They can range from simple networks consisting of two computers to networks connecting millions of devices. So uh, there are many sizes. The first one is the small home network. So it is from the home. So it just connecting a few computers. Then the next one is the small office or the home office network. So it is more computers connected. Then small to large network. So it can connect more. So it uses in the school. Then the worldwide network. So it is from the worldwide. So it can connect the different countries. Networks must be reliable. It says here that the network must be reliable. This means that the network must be fault tolerant, be scalable, provide quality service, and ensure security of the information and resources on the network. Focus first on the fault tolerance. So the fault tolerance is the expectation is that the internet is always available to the million of users who rely on it. So it must be always available. Then the be scalable. Network can expand quickly to support new users and applications without impacting the performance of the device being delivered to existing users. So it must be expandable. So even though uh, it has many users, so it will not impact the performance. Then the provide quality service, also an ever increasing requirement of networks today. So we should provide the quality of service, then ensure, and then the security. Securing a network infrastructure includes the physical securing of devices that provides network connectivity and preventing unauthorized access to the management software that resides on them. So the security is very important. So it must be all layers should have a security. The Cisco iOS or this one is the operating system. So the PC. OS or the operating system allows user to interact with the computer. So user-computer interaction in PC OS are often done by a mouse, keyboard, and monitor. So the interaction between the user computer and the PC is via mouse, keyboard, and monitor. The Cisco iOS is also an operating system. The Cisco iOS allows users to interact with Cisco devices. Configuration command modes. The configure terminal command enters the global configuration mode. So, uh, sub-configuration modes are accessible from privilege exec mode, example switch config and switch config if. So, if you are in the privilege exec mode and you want to go to global configuration mode, so you will just put the configure terminal or the config T. Then navigate between the iOS modes. Navigation between modes is also done via commands. The enable command enters the privilege exec mode. The exit command exits the parent command mode. So, like for example, you are in the user exec mode and you want to go to privilege exec mode, so you will just type the enable command for that. Then exit, so it will exit to the parent command mode. Communication. So here are the rules. Rule establishment. Identify sender and receiver. So you need to identify first the sender and the receiver. Then common language and grammar. So what language that you will use. That speed and timing of delivery. So it is very important for you to understand each other. Then confirmation or acknowledgement requirements. So message encoding process of converting information into another acceptable form. So you will encode uh, your message. Then message formatting and encapsulation. The message size. So uh, the message size is very important because if your message is too long, so the receiver will having a hard time to understand the message. Then the message timing, we have the access method, flow control, and the response timeout. So message timing. So it's about your timing. So uh, if the two people communicate or talk at the same time, so you will not understand each other. So you need to have the message timing. Then message delivery options. So the unicast. So the unicast is it is from one person to another person. So it's like a one-to-one communication. Then the multicast. So it is from one person to a group of people. Then the broadcast is from one person to all the people. So again, the difference of the unicast, multicast, and broadcast are the unicast is for one-to-one communication. Multicast is from one person to a group of person or a selected person. Then a broadcast is the from one person to all data encapsulation. Message segmentation. So the segmentation is the break communication into pieces. So when we are segmenting, so we are breaking the communication into pieces. Then for the receiver to easily understand it. Then the multiplexing, interleaving the pieces. The data decapsulation. This process is reversed at the receiving host and is known as decapsulation. Access. Physical layer protocols purpose of the physical layer. So, the physical layer accepts a complete frame from the data link layer. This is the purpose of the physical layer. It is accepts a complete frame from the data link layer. So it it says here that it accepts a complete frame. It is from the data link layer. Then encodes it at a series of signals that are transmitted onto the local media. So it encodes to transmit to the local media. The physical layer protocol. So this is the physical layer characteristics. So the function, physical components. So the physical components is the physical or like the PC, the laptop, so the router or the and devices that encoding. So you will encode that or you will put the message, the signal, data transfer, the bandwidth, capacity to a medium to carry data. So the meaning of the bandwidth is the capacity to a medium to carry data. The throughput, it is used to measure or of the transfer of bits across the media. Then the types of physical media. So this is the physical media. So I think this one is uh, the router or the switch. So again, this is the switch. So you can see these are they have the USB Type A connector. Then you can see also the Gigabit Ethernet interfaces, the management ports, then the SHDSL interface, and then the fast Ethernet switch ports. So the network media, copper cabling, characteristics of copper cabling. So inexpensive. So the uh, copper cabling is inexpensive. So it means that it is cheap, then easily to install, low resistance to electric current, then distance and signal interference. So the copper media. So there are the different types. So the unshielded twisted pair or the UTP. So you can see that in the left part. Then the shielded twisted pair and then the coaxial cable. The copper media safely is the fire and electrical hazards. Physical topology refers to the physical connection and identifies how end devices and infrastructure devices such as routers, switches, and wireless access points are interconnected. So the uh, physical topology is it identifies the how the end devices. So end devices like the PC, the printer, the laptop, the switch, the router, uh, access points are interconnected. Then the logical topology refers to the way of network transfer frames from one node to the next. This arrangement consists of virtual connections between the nodes of a network. These logical signal paths are defined by data link layer protocols. So uh, this is the uh, picture of the logical topology. So it is more on the nodes, the logical topology. Ethernet frame. Ethernet encapsulation. So Ethernet operates in the data link layer and the physical layer. So we can see or the Ethernet operates in the data link layer and the physical layer. So Ethernet supports data bandwidth from 10 Mbps through 100 Gbps. Then the bandwidth of the Ethernet is from the 10 Mbps up to 100 Gbps. Then Ethernet standards define both the layer 2 protocols and the layer 1 technologies. MAC sublayer. MAC constitutes the lower sublayer of the data link layer. So it says here that the MAC sublayer it constitutes the lower sublayer of the data link layer, then responsible for data encapsulation and media access control. So It says here that the MAC sublayer is the responsible for the data encapsulation and the media access net control. Then, Ethernet evolution. Ethernet has been evolving since its creation in 1973. So, the Ethernet invented or created in 1973, the Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and the maximum is the 1518 bytes. So, uh, the minimum of the Ethernet frame size is 64 bytes and the maximum is 1518 bytes. Then, frame smaller than the minimum or greater than the maximum are dropped. So, it is if the frame is smaller than the minimum, so it will be dropped. And if it is also greater in the maximum, it also drop also. Then drop frames are likely to be the result of collisions. So the drop will be the result of the collisions or other unwanted signals and are therefore considered invalid. Forwarding methods. Frame forwarding methods on Cisco switches store and forward. So it means that after it's stored, it will be forward. Then the cut through. Cut through switching. Fast forward switching. Lowest level of latency immediately forwards a packet after reading the destination address. Then in the cut through, it will not store. Uh, uh, while the store and forward, so it will store first, then it will forward. Then typically cut-through method of switching, fragment-free switching. Switch stores the first 64 bytes of the frame before forwarding. Most network errors and collision occur during the first 64 bytes. Then memory buffering on switches, port-based memory and the shared memory. Switch port setting, duplex and speed setting. Full duplex, both ends of the connection can send and receive simultaneously. So in the full duplex, so uh, uh, the two PC can send and receive the data at the same time, simultaneously, while the half duplex is only one end of connection can send at a time. So in the half duplex, so one PC will send at a time, and one if the one PC will send, the another PC will receive. Then uh, in the short term, so it is one at a time. Then common cause of performance issues on Ethernet links is when one port on the link operates and at half duplex and the other on full duplex. Calls. Network layer in communication. The network layer end-to-end transport process, addressing, and devices. So first is the end-to-end transport, then addressing and devices. So I think that is the IP addressing of the IP of the end devices. Encapsulation, routing, and decapsulation. Network layer protocols. So we have two different IP. So we have the IPv4 and the IPv6. Characteristics of the IP protocol. Encapsulating IP. Segments are encapsulated into IP packets for transmission. So it says here that the segment, it will be encapsulated into packets to IP packets for transmission. The network layer adds a header so packets can be routed to the destination. So the IP is connectionless. So sender doesn't know if the receiver is listening or the message arrived on time. Receiver doesn't know data is coming. So connectionless means that they doesn't have any connection. So the sender doesn't know if the receiver is listening, or it also didn't know if the message arrived on time. Then IP, best effort delivery. No guarantees of delivery are made. So, but they are making their best effort to deliver the data or the message. IP media independent. IP can travel or over different types of media. So it says here that the IP is in the media independent. So it can travel into different types of media. Configuring a Cisco router. Configure initial settings. So the basic switch configuration steps. So uh, we will configure first the switch. So that is a configure device. So that is the host name. So the host name for that is just like the command for that is the host name space the host name that you want, and secure the exact mode. So you will use the line console 0, then the password you want, then you will log in. Then the secure BTY lines is the uh, that is a line BTY 0 space 15 because it has a 16 ports. So in programming, we started counting at 0. So that's why it is a 0, 15. Then secure privilege exact mode. So that is the enable secret. Then in any password you want. Then secure all passwords. So trying to secure that. So you will use the service password encryption command. Provide legal notification. So this is the banner. The banner. So the command for that is the banner space MOTD, then the quotation, then the banner you want, and then the quotation, closing quotation, then save the configuration. So copy running config, startup config. So same as the router configuration. So maybe the uh, here the configure the management SVI. So I forgot that. So that is the interface. Uh, And for the SBI, so we will just you will just put the IP address of the IP address and the subnet mask of the switch. So the difference is in the router, so we will use the gigabit Ethernet 0/1 or 0/2. So in the switch, so it is the interface, then the VLAN 1. So in the router, so interface gigabit Ethernet 0/0, 0/1, and so on and so forth. The rest, they are the same command. Configure the default gateway. Default gateway for a switch. A default gateway is required for a remote network communication. If a switch is to be managed via its VTY lines, it needs a default gateway. Use the IP default gateway command to configure the default gateway for a switch. So that's all for this video. Thank you for watching. IPv4 network addresses. Binary and decimal conversion. IPv4 addresses consists of string of 32 bits divided into 4 sections called octets. Each octet contains 8 bits separated with a dot. So just like this one. So the 192.168.10.10. So they are separated with a dot. So that is in binary. So 11000000, and for the 168, so that is 10101000. Then in 10, so that is a 00001010. So again for 10 is 00001010. Conversion between binary to decimal. use the chart to help with conversion. So you have the positional value. So let's start with 10. So we will convert that decimal 10 into binary. So uh, you will ask if 10 is greater than or equal to 128. So if no, so you will put 0. So 0, 0. 64 also is no. 32 also is no. And the 16 is also no. So the 8 is 10 greater than or equal to 8? So yes, so we'll put 1 there. Then next is 10 minus 8, so it is a 2. Is 4 greater than or equal to 2? So no, so that's why it's 0. Then it's 2, and 2 is greater than or equal to 2, so yes, so that's why it's 1. Uh, then 0 to 1, so just like that. The IPv4 unicast, broadcast, and multicast. IPv4 addressing assignment to a host. Static, type in manually. Uh, so you will type manually for the static. For the dynamic, so dynamic host configuration protocol or the DHCP. So it is a configure also. Then IPv4 communication. Unicast send packets from one host to an individual host. So the unicast is from one-to-one connection. Then broadcast is send packets from one host to all the hosts in the network. So the broadcast is from one host into all of the hosts. Then the multicast send a packet from a one host to a selected group of hosts in the same or different network. So the multicast is it is from one host to a selected group of hosts only. So again, the unicast is from the one host to one individual host. Then the broadcast is from one host to all the hosts. Then the multicast is from one host to a selected group of hosts. Then IPv6 addressing, IPv6 address representation. So the x colon 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 and x, where x represents 4 hexadecimal values. Apply the rules to simplify these IPv6 addresses. Rule number 1, omit leading zeros. So in IP addressing, so you will just omit the leading zeros. So if it start with 0, so you will just omit that or remove that. Rule number 2 is omit all 0 segments. So just like this one. You will just omit all the 0 segments. So if the segments are all 0, so you will omit that. Then types of IPv6 addresses. IPv6 address types is the unicast, multicast, and telecast. So just like in the IPv4, so the unicast is from one host to another individual host. Then the multicast is from one host to a selected group of hosts, and then the anycast is for any one host to any host. Then testing and verification. Ping. Testing the local stack. Ping is a testing utility that uses ICMP echo request and echo reply messages to test connectivity between hosts. Ping works with both IPv4 and IPv6 hosts. Ping testing connectivity. The local LAN. You can also use ping to test the availability of the host to communicate on the local network. This is generally done by pinging the IPv6 or IP address of the gateway of the host. A ping to the gateway indicates that the host and the router interface service as the gateway are both operational on the local network. Ping, testing connectivity to remote. Ping can also be used to test the ability of a host to communicate across an inter-network. The local host can ping an operational IPv4 host of a remote network. So, ping testing the local stack. So, the for the summary of this, so the ping is uses the it used to test the connectivity. So, for example, so you have the two networks. So you want to and you have the PC 1, 2, and then the other network has a 3, 4. So they're both connected to a router. So uh you if you want to say to test their connectivity, so we'll just ping the just like for example, you will use the PC one. So you will ping the or test the result test the connectivity between PC1 and PC4. So you will just type in the command prompt. So you will just type the ping and the IP address of the IPv4. Then if you got 4 replies, so it means that you have the connectivity. Subnetting is the strategy used to partition a single physical network into more than one smaller logical subnetworks or the subnet. So it says here that the subnet is used to it's like to divide the physical networks into the smaller logical subnetworks. An IP address includes a network segment and a host segment. Subnetting helps to reduce the network traffic and conceals network connect complexity. Subnetting works by applying the concept of extended network addresses to individual computer and another network device address. But because this is a Class C network, the default subnet mask of 255.255.255.0 allows all computers on the network to be peers to send the message directly to each other by default. So it uses the subnet mask of 255.255.255.0. A subnet mask is used to divide an IP address into two parts. One part identifies the host or the computer. It the the IP address is used to divide the IP address into two. So the part one is used to identify the host or the computer, and the other one is part is to identify the network to which it belongs. To better understand how IP addresses and subnet masks work, look at an IP or the Internet Protocol address and see how it is organized. The main purpose of subnetting is to help relieve network congestion. So it says here that the main purpose of subnetting is to help to relieve the network congestion. So to prevent the congestion, so we are doing the subnetting. Congestion used to a bigger problem that is it is today because it was more common for networks to use hubs than switches. So the network is um, it uses or use hubs than switches. When nodes on a network are connected through a hub, the entire network acts as a single collision domain. Registered ports. So the numbers 102 to 49,151 are assigned by IANA or the IANA. So requesting entity to use with specific processes or applications. These processes are primarily individual applications that a user has chosen to install, rather than common applications that would receive a well-known port number. For example, Cisco has registered port 1985 for its Hot Standby Routing Protocol, or the HS. Transportation of data. Role of the transport layer. So this is the role of the transport layer, responsible for establishing a temporary communication session between two applications and delivering data between them. So the transport layer is responsible for establishing a temporary communication, provides connection-oriented data stream, support reliability, flow control, multiplexing. Transport layer responsibilities: track individual conversations, segment data and reassemble segments, identify the applications. Conversation multiplexing segments data into small chunks. So, segments data into the multiplexing is the segmentation. So, it divided the data into small chunks. Then, label data chunks according to the conversation. Transport layer reliability. Two protocols provided: TCP and UDP. TCP supports reliability while UDP application, presentation, session. Application layer. So let's start with that. Closest to the end user. So since that uh, it is the last part of the OSI model, so that's why it is the closest to the end user. Application layer protocols help exchange data between programs running on the source and destination host. The TCP/IP application layer performs the function of the upper three layers of the OSI model. Common application layer protocols include the HTTP, hypertext, and the FTP, TFTP, and the DNS, or the domain name system. Then presentation and session layer. Format data, compress and encrypt. So in the presentation and session layer, so it formatted the data, then compress or make it short or small, then encrypt data for security. So they encrypt the data. Then common standard for video include QuickTime and motion picture experts group, or the MPEG. Then common graphic images formats are the GIF or the GIF, the JPEG or the JPEG, and the PNG or the PNG. So the GIF, JPE, JPEG, and the PNG is the we usually see this one in the extension for the pictures. Then the session layer creates and maintains dialogues between source and destination applications. The session layer handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle. Network design devices in a small network. Small network topologies comprises one router, a couple of switches, and the user PCs. So, uh, small network topology. So, you will just have a one router, a couple of switches or two routers, and user PCs. Access to internet through a single WAN or the wide area network link, cable, or DSL. Management, usually by a third-party company. Device selection for a small network. Security, call top service, the VoIP, L3 switching, NAT, and the DHCP. IP addressing for a small network. Address space is a crucial component of a network design. All devices connected to the network require an address. The address scheme must be planned, documented, and maintained. Address space documentation can be very useful for troubleshooting and control. Address documentation is also very important when controlling resource access. Redundancy in a small network. So the redundancy is the repetition in the small network. A network should be reliable by design. So in design, it should be a reliable. Network failures are usually very costly. So when the network fails, so it is very costly. Uh, Redundancy increases reliability by eliminating single points of failure. Traffic management. Traffic type and patterns should also be considered when designing a network. A good network design categorizes uh, traffic according to prior troubleshooting methodologies. Basic troubleshooting approach. Identify the problem first, then establish a theory or probable cause. Test the theory to determine cause. Establish a plan or action to resolve the problem and implement the solution. Verify full system functionality and implement preventative measures. Document findings, actions, and outcomes. Resolve or escalate, verify, and monitor solution. Troubleshoot cables and interfaces. So the duplex operation and duplex mismatch. So thank you. That's all for this video. Thank you for watching.